This is Kelly Hill, Executive Editor with RCR Wireless News. I'm here today with Rohan Thomas, who is an industry analyst with Frost Sullivan. And we're going to be discussing big data analytics in the service provider context. Rohan, how are you?
I'm good, Kelly. How are you?
Good, good. So you put together a recent report on this topic. And so let's talk a little bit about what some of the major trends are that you're seeing in the area of data analytics for service providers.
Sure. So Internet of Things is number one on this list of trends. And as you probably know, Cisco, as per the Cisco VNI reports, they have forecasted traffic from M2M applications to grow by at least 70% between 2016 and 2021. And key areas within Internet of Things, according to our research, is automotive and healthcare. Then you have smart cities, which basically is like verticals such as automotive and healthcare being, connected with public utility. So that's also getting there's a lot of growth there. And when you have a lot of these verticals and getting connected, there are a variety of connected modules of various bandwidths that are also going on to the network infrastructure. So that's number one. And I'll go through these trends, and I'll later on tell you what the relevance this has on data analytics. So I think it's important that we actually go through this first. So after Internet of Things, we have augmented and virtual reality. I thought I'd just run you by the definition. So augmented reality overlays a computer-generated simulation over the user's vision sight without obstructing the user's sight of the real world. And virtual reality immerses the end user into the computer-generated simulation. And this is kind of the main difference. And some of the examples would include for augmented reality applications like Snapchat and Pokemon Go, and virtual reality would be Google VR, Cardboard, and the Meta Viewmaster, etc. Over the course of time, this is actually being more and more commoditized, with the VR headsets costing as low as $15. So there's a lot of traction. And smartphone manufacturers anticipated this, and then you have guys like Qualcomm actually incorporating LiDAR technologies into their processes to make it more AR compliant. The problem is, bandwidth requirements become an issue, and it's not. If all of these devices and applications come on board, then it's going to be a huge problem in terms of bandwidth constraints. The next leap here would be virtual reality, where you immerse the user completely. So that would include your sense of smell and even taste. So, but again, for that to be done, there'll be huge, requirements for network bandwidth. After that, we have video streaming services. So the ones that come to my mind are Netflix, Hulu, Amazon. From where I sit, I see a lot of activity here. It's been enjoying substantial degree of growth. And there are interesting developments. You've seen the acquisition of Time Warner by AT&T. And then in addition to this, you have network operators who actually offer zero rating services, and wherein they actually offer these packages to the end user at no additional fee. In a sense, they are not charged for the data charges. So these are the three mega trends. Now, how does it actually fit here? What is the relevance? Well, these actually justify the case for a better network deployment, such as 5G. And it's because it has substantially higher throughput, has enough bandwidth, and to actually support those critical applications that would require high bandwidth application, as well as bandwidth that is just adequate for low-powered IoT devices. And in order for you to do that, you need there'll be network densification, network virtualization, and pretty much a re-engineering of the RAN to make it a little bit more efficient. Now, because of this is in essence what justifies the requirement of a data analytics solution. So, because when you actually deploy this, you would require an analytics solution which strong automated and machine learning capabilities that can actually predict and analyze what the future data traffic could be using geolocation capabilities, identify where the major congestions are across cell clusters and try and neutralize them. And another thing about the IoT use case is because you have a lot of these connected devices that are multi-vendor and also, connect to specific network deployments, there could be a lot of confusion amongst the devices just to understand which specific network they need to tap into. And that is where lifecycle management kick in, where you have specific data analytics solution providers offering solutions that can have the entire lifecycle management. And this basically kind of goes through a series of iterations where it keeps repeatedly testing and then reconfiguring and optimizing the specific cellular configuration until it reaches the optimal level. And with this predictive analysis, it kind of contains this unforeseen battery drain that most connected devices could go through when they're trying to tap to a network. One more relevance of this before I'm done, before we go to the next question is the video streaming part. It's constrained again by a network bandwidth requirements. These video streaming service providers would obviously want to give a really good media content with very high resolution. But again, you have bandwidth requirements, and in order for you to, it also depends upon the type of end user that this specific content is being streamed across to. So you would also require certain traffic shaping tools which can actually figure out what the kind of end user device is, and therefore kind of reduce the resolution based upon the type of the device. And also, as I earlier mentioned, you have zero rating services, right? So it should basically kind of understand which specific, if you have a subscriber, whether he's actually you're tapping the feed via a zero rated service or whether it's through a separate Netflix account or something, and thereby charge him accordingly. So they don't overcharge him or undercharge him, which could actually have severe consequences, not just from a monetary point of view, but from a brand image point of view for the network operator. So these are some of the trends.
Yeah. Okay, great. Well, those are some, yeah, and those are all very relevant trends to the industry right now. So I think one of the questions that that I'm interested in is I hear a lot of big data analytics can is capable of anything. A lot of promise and a lot of, I think, hype maybe. So what's the promise versus the reality of the capabilities of big data analytics?
Okay, before we begin, I think it's best we go through the definition. Okay. So from a communication testing point of view, a data analytics solution is basically one that actually enhances the visibility of the data traffic. It basically and tries to helps the operator enhance the quality of service on the network infrastructure. Okay. Most data analytics solutions that are out there, they're very powerful and they give excellent insights to the user from any specific vertical about trends in this industry and what he needs to do. But the key differentiator is the ones that the communication testing vendors actually provide. Well, these are actually able to tap into the encrypted data feed, and that's a key differentiator. And about 75% to 80% or even more of the network data is encrypted. So when you talk about some of the other data analytics solutions that many of you are aware about, it just stops right there. It doesn't actually try to, they don't come with the capability of actually understanding the quality of the encrypted data traffic. So that is the specific definition. Now, in terms of promise, I think it's best if we cover the expectations. What are the expectations of the network operator? And they're looking for a solution that can actually that will help them understand which specific area the feed is coming from, the source. It could be a wireline or a wireless, and the type of quality in the sense which area of the infrastructure is actually needs to be analyzed if there's a kind of a drop in quality, and also the kind of application that the end user is using. For instance, if he's using, he needs to know, the operator needs to know when the specific degradation took place. But if he was using a specific Facebook application, and if it was a Facebook application, what exactly in it was he using? Well, was it a video stream? And if a Facebook application was in a zero-rated service, in its terms and agreement, was that video stream that you streamed also part of the zero-rated service, etc. So that actually has a lot of implications. So this is the kind of information that they actually look for, and this is something that most other data analytics solutions, they can't analyze. And so these are the expectations. Now, in theory, that is all what a good data analytics solution is supposed to do. Now let's put 5G on top of this. As I mentioned earlier, I was trying to make the case as to why 5G is kind of important. But because you have, it's being talked about a lot in the industry, when it does come out, you have, say, network densification, you have network slicing. So a whole lot of virtualization and a whole lot of network cell clusters that needs to be looked into, trying to understand, do a very thorough fault analysis and optimize these cells. And also, because it's a virtualized environment, it's not completely virtualized, but it's getting there. So it's usually a hybrid environment. So because you have a bit of a physical and virtual, you need to have a data analytics solution that can be easily deployed across a mix of both physical and virtualized. So the expectation is they require a solution that is extremely pervasive, that can be easily deployed across the network infrastructure. And this network infrastructure is often multi-vendor. Now, how does the net testing community address this? Well, first of all, they're actually moving from probing solutions that were predominantly hardware-based to ones that are more software-based. And they're trying to do this to make it lightweight. They're trying to, so that they're easy to deploy, and obviously, and also a lot more scalable than its predecessors. And remember, I was telling you about the IoT use case, right? About the connected device that kind of gets confused, trying to figure out which particular network deployment to tap. So they're also looking at enhancing their data analytics solutions with enhanced automation capabilities, machine learning capabilities, lifecycle management capabilities that can do these periodic iterations until that optimal efficiency or throughput is is realized, and also that comes with really good predictive analysis as well. Now the challenge here, however, is customer outreach. Now this is actually a really key variable. You have network operators who have like DT, who have a really good IT network engineering team in terms of competence, who can actually integrate such a solution in a smaller frame of time. But then you could have other operators or service providers that would take a lot more time. So that is a key variable, and that obviously translates into a lot of money. And the other one would be the fact that they don't, as yet, I don't see a solution which actually can go through the entire network infrastructure that consists of the mobile edge, the RAN, the transport, and the core, in terms of offering an end-to-end performance and visibility. That's the context I was talking about. Okay. And right now, the mobile edge is actually growing at a significantly higher rate. And so this is an area where the testing and monitoring equipment, they are addressing it, but they should probably address it, even further, so that connected chain is missing. So that's one issue. But then over time, like with any other market, they should, these markets have a way of self-diagnosing themselves and kind of coming over it. So these are some of the challenges that they face.
Okay. Can you talk a little bit about regional differences? What are you seeing in different parts of the world in terms of how operators are approaching this?
When you look at North America, I am, as you see, a direct correlation between the traction of technology and the kind of activity there is in a specific region. So when you look at North America, there was it's being led by the US, and there was a merger of T-Mobile with Sprint, which enhanced the degree of consolidation amongst the service providers community there. And what T-Mobile and Sprint right now are trying to do is trying to use the 2.5 gigahertz and the 600 megahertz from T-Mobile and Sprint to kind of use that space to better innovate 5G use cases and applications, and try and make it more affordable. So then we have the acquisition of Time Warner by AT&T, and with that they entered the video streaming services space. So these activities give a whole lot of use cases that the testing and monitoring vendors can use and monetize upon. So the North America is a very has always been a very attractive region for the communication testing market. And another reason for that is if you look at the key participants, a lot of them, the top ones, are actually based out of the region. So that actually kind of gives truth to why North America is actually more important than the rest. Europe is almost similar in size. It also has a lot of the similar trends. They also have a very well-established 5G and 4G network in place. They have a very high mobile penetration rate. Both of these regions, instead of acquiring new greenfield customers, are instead trying to reduce customer churn by actually enhancing the QoE and the QS, and also providing other value-add services, such as the many services through these zero-rated applications.
Okay.
And key operators there, like BT and Deutsche Telekom, Telefonica, they are also doing substantial work in the 5G space in terms of testing. And then you have APAC. Important countries would be Australia, China, India, Japan, Singapore, South Korea, who are all engaged in 5G testing. As per our analysis, we believe that KT and SK Telecom would possibly launch 5G services sometime in next year. And this would be followed by Telstra. And then you have NTT Docomo who are also launching 5G by the time of the Summer Olympics in Japan, summer in 2020. India and China are quite interesting. And they are conducting extensive 5G tests. But if you take, let's say take a country like India, while they're doing a lot of testing on 5G in a bid not to stay behind, in terms of LTE proliferation, they are not as mature as many of the other countries. So there's a lot of room for left for LTE, network deployments to grow. And these regions, because of the fact that LTE, there's still a lot of room for LTE networks to grow, and because the network authorities or regulations there are not as stringent as many of the other places, that would not still warrant a full-fledged data analytics solution which has all the capabilities that one would require for, say, a 5G, or which has revenue assurance capabilities as yet. So that's probably another reason why it's a little behind in this specific region. Also, in terms of data and encrypted traffic, Asia is actually slightly behind in comparison with North America and Europe. So that is also another reason to give network operators that not to actually acquire a full-fledged data analytics solutions. Like they would rather go to a system integrator and tell them what this problem is, and then they get a customized solution. Okay. Middle East and Africa, well, with the exception of GCC countries,
okay,
the other places they don't have. It's predominantly legacy-based 2G and 3G, and therefore, as I mentioned earlier, it still does not make a business case for a network testing vendor to actually offer a solution to track a solution that is a network that is so legacy based. In the GCC, however, you have countries like the United Arab Emirates, Saudi Arabia, Qatar, who are actually making substantial headway in terms of 5G testing. Ooredoo actually launched limited 5G services in Doha that are actually restricted to specific venues. So that's the kind of development that we see there. So the GCC countries are what's probably propelling the use cases for data analytics solutions. But aside from that, it still seems very premature. They don't. It's not there yet to actually have a data analytics solution.
Okay.
I'm sorry
Great.
about my cough, though.
Oh no, that I have a little bit myself. So wow, that's a really comprehensive view of the world, and I think you've hit on the major trends, you've hit on some of the drivers for this. What's in store in this area? What do you see coming? In the next few years?
Well, right now, okay, we do see a demand to grow, but it's only up to a specific point. After that, it's not as though it's going to go down or anything like that. But the reason why it's up to a specific point is that a lot of the network operators, they want to see a successful transition to another 5G service. So right now they're doing a lot of testing before the service is actually deployed. So that's one of the reasons why solutions such as this would substantially go up to a specific point. And that's one specific trend that I see in terms of, say, forecast. And then these data analytics solutions. Right now, I see data analytics solutions that look at traffic that is generated by subscribers like you and I, and then you have many other IoT use cases that are coming. So there could be a gradual shift in the importance that network operators place and therefore allocating resources from, say, tracking subscriber-based traffic to some those that are non-subscriber, like IoTs and specific traffic, etc. And right now, as I said, there is no solution that is truly end-to-end, but this market has seen a substantial degree of consolidation. And one of the reasons why they do that is to try and do just that, make that end-to-end, get the ecosystem and make that solution a lot more beneficial for the network operator. There are many such acquisitions, but one such acquisition is probably the acquisition of SLA by Expo. That enhances the company's passive monitoring and analytics capabilities, and at the same time, substantially increase their geographic outreach across the EMEA. So that's just one example of many.
Yeah, that was a big one.
Exactly. So this degree of consolidation should continue, and gradually over time, testing and monitoring vendors should be able to give a solution that actually covers the edge, the radio, the transport, as well as the core. And in order for the operator, for the testing vendor to enhance the cost efficiency of their solution, they're trying to move towards a more passive, software-based approach, and that's you will see that gain a lot more steam in the future. So they can actually cover a lot more ground, a larger demographic in a shorter period of time. And right now, there's a lot of disaggregation in terms of policies and technologies, such as, for instance, the implementation of open source code, how that could go against the interests of, say, vendors who are trying to source their products to their end users. But over time, there'll be a lot more clarity, and then the ecosystem would actually kind of move around it, and as it becomes more mature. So those are some of what I probably see in the future.
Okay. Great. Well, thank you, Rohan. You covered a lot of ground. So thank you so much for the perspective. I think this is going to be a really interesting market to watch, and we appreciate your insights.
Thank you. And it is a very dynamic one. And let's see how it's going to turn out in the future.
Okay, great. Thank you so much.
Thank you.